Hey, I'm going to show you guys how to analyze a data set of an exoplanet transit. So I just opened astroimageJ, so I have the basic tool open here, and then I have the data from May 13th installed on my computer. So I just have a separate folder here, right? And then it's all of the images that we took of the particular transit. So from 0 down to 135. Okay, so in astroimageJ, we're going to do file and then import, and we're going to import an image sequence. So that's going to open up. So we'll go back to my exoplanet folder. And it's basically, it'll pull in all the images from this particular directory. So I'm going to say open that. And then this popped over to the other monitor. Okay, so it's telling me that I have 128 images, blah, blah, blah. That's all fine. And then for this, we usually just do a virtual stack because it's a lot of images to upload. So we say OK. And again, that popped up to the wrong screen, so I'll just bring that over. And here is the image. And we need to find out what actual object in the field of view is actually the exoplanet. So I should have done this before, but I didn't. So we'll go to the Swarthmore exoplanet website. We're going to say that we want to know, not today, but we want to see what transits were available on May 13th. That's when we took these data. And then just within 1 day of that is fine. And I usually do a minimum of 10 parts per thousand. So let's click on that. Okay. All right, so here's the one that we did, hat P44B. So it was 3 hours that we followed this transit. And so the thing that's nice here is that there's a lot of information that you guys will get used to as you use this more and more. But we want to look at a finding chart, right? So let's look at an annotated one. Okay. Now this is a little bit different. This is saying north is up and east is to the left here. In this one, where is my north? North is to the left and east is down there. So not ideal. But I have done this before, so I kind of know what we're looking at. But also, you also want to look at the field of view. So this is a 40 by 40 arc minute field of view. Our imaging camera's got like, I don't know, 29 by 15 or something like that. Oh, here it's saying 4.5 arc minutes there. Anyway, the thing that I focused on when I did this before was this little triangle here, right? So it's like a long side and a short side. And if I look over here, it's a little bit hard to pick out, but this is the long side and that's the short side. Again, remember this whole thing is 40. This is like 10 arc minutes here, right? So this little center part is what we're seeing in our image. So this one here is the exoplanet, or that's the star that's got the exoplanet going around it. Okay, so let's move this back out of the way. And then, all right, so what we're going to do then is put down some apertures. So we're going to perform multi-aperture photometry. So that's right there. And we'll click on that. Again, everything's opening on the wrong monitor, whatever. Okay. So we could actually click through and select the object in every field of view. But if you click through the image slice here, so you can actually slide this. Oh, wait, so let's cancel this. So you can actually play and have it scan through all the images. So we see actually like little asteroids that are going on, but we see that the objects are kind of moving in the field of view. And now we're going to see a big, this is our, we had some rotation problems. So this is our triangle afterwards, but you can see that the object actually moved all around the field of view. So it's definitely not ideal. We just had some issues with the rotator that night, and so we weren't able to keep it in the exact same position. But if we look through that again, right, so we can see we weren't guiding either, so we can kind of see that things are drifting to the left a little bit. And then we had a really big rotation there, and then our derotator wasn't working, and then we reset everything and kept observing. So the last part is actually a little bit steadier. So, so you can go through and actually pick up what the object is in every field of view, or we can tell it since. Can you notice it? Yeah. So if I move my mouse around on the screen, if you look up here, when we talked about coordinates, right, ascension and declination, you can see that they're changing first of all, and it actually knows what they are in this image. So the data we actually put it through the pipeline that we have for reducing data from our the Brea Observatory, and it already has the RA and DEC on it. So that's really useful because what we can do now with this data set, especially because of the fact that we have these big shifts and rotations between the different objects, we can use the right ascension and declination to locate aperture positions. So this is an option that you could try doing the single step mode, but I'm just going to have it do it automatically. Okay, so let's see. We're gonna. Okay, yeah. So you can actually pick the aperture, how big it's going to be, like what the radius will be, and then let's see if I put it down here. So basically, you're going to have like an inner circle where you measure the flux, and there'll be a gap, and an outer annulus that you try and measure the sky value, which is, for any part of the image here, there's counts aside from just there being an object, a star there or something, right? So you want to be able to subtract that off so that you're just getting the counts from the star. Okay, so I'm actually going to do this where I'm going to vary the aperture size based on the full width f max, because our image quality can change during the course of an observation sequence. So sometimes the things can come a little bit out of focus. And in fact, if you look in detail at some of these images, the focus got pretty bad. And so this option will actually expand the size of the circle that we're measuring flux in based on what's happening in that particular image. Okay, so we have that looks good, and then we'll just place the aperture. So the first thing you want to place is the star that has the exoplanet. We call that our target star. And you can actually see now where my mouse is. There's the red cross that's showing us the center location, and then there's an inner circle and an outer circle showing us where the sky is going to get measured. So I'm going to click on that. So that is my target. And now I want to have a couple of comparison stars. So I'm going to click on this guy. And we'll do this guy as well. And maybe like some of these fainter ones are not going to give us great measurements, but we can try. Maybe that guy. And I'm not sure if this one's on the field of view all the time. Might be. Let's try it. Okay, so when we're ready, so I'm just doing a left click there. I picked the target, picked some comparison stars, and now I can do, oh, and by the way, I'm not using these that look bright because I know that they rotate off the field of view in other images. Okay, so now I'm going to right click. All right, and then a bunch of images opened over here. This is kind of the most important thing. So we can see it's actually able to follow where all these things are, right, through every image. And it's showing us the real time what the photometry is that it's measuring. And there we go. So let me bring all these other images. These probably opened up for you too. They just opened up again on my other monitor, so I had to bring these all over. Okay. All right, and let's pause there, and then we'll do a second part for doing the analysis. But if we just do a quick look here, we have, this is our image. It opened up a bunch of other plots. This we're going to look at for trying to fit the data. This is lots of details here about what we can be plotting in this graph. Oops, did I do that? Okay. So we want to do an auto scale. Let's do that, and then update the plot somehow. Okay, so let's pause there, and then we will go through how we actually try and fit the data. But so this, by the way, is just a table of everything that it measures for every image that we're looking at. So it's got the image numbers going down here on the left, right? So there's a row for every image, and then there's going to be information about here. T1 is our target, and then comparison stars. 2, 3, 4, 5.